Okay, so it is currently 1:43 a.m. So it's the second day after I took my algebra paper here. But before we get into the actual paper, I'll show you guys the cheat sheet I was allowed to bring into the exam. Now, I didn't actually make this one myself from scratch. This is actually, I kind of stole it. I'll be so honest. The person who's best at algebra in my course was making their cheat sheet, and they agreed to make it for other people. And then one of those other people that they made it for sent it to me. But this was the unfinished version, because the person who was making the cheat sheet got extremely drunk the day before the exam. But that's a different topic entirely. Getting on to this, here you can see some screenshots of lecture notes. I don't know if that's clear enough for you to read, but yeah, there's some stuff about long division here. They put this in every single cheat sheet. I don't know why, because if you forget what the complex numbers are, I really don't know what to tell you. But yeah, we got some corollaries about inverses and stuff. What else we got here? Some definitions. Yeah, I always say, oh yeah, they highlighted Lagrange's theorem, which is very useful, I will say. But I've always wondered, like, a lot of people in my course make their cheat sheets look like this, just a bunch of screenshots or like a bunch of tiny writing. And I always ask them, now navigate it. Go on, navigate it. Find the fundamental theorem of homomorphisms in your notes in 30 seconds. Because in exam conditions, you ain't gonna have time to just be, dilly-dallying around, using your finger to read through everything. But yeah, the screenshots are what they put themselves. This little writing on the side here is what I added in the end. What I had, I said subgroups of an abelian group are normal. As we put in the definition of normal. Yeah. Honestly, I put these other three conditions down here as if I would be able to prove them in an exam. No idea how I would do that. If two cosets have share an element, they're the same coset. If the order of G is double that of the order of H, then H is normal in G. Fields only ideals are itself in 0, ideal definition. This one, I don't know what I was planning to do with this information, to be honest. Oh yeah, no, maybe build quotient rings with it. Yeah, okay, never mind, that's why. Polynomial of degree 1 is irreducible. Don't know why I had to write that down. Polynomials of degree 2 or 3 that have no roots are irreducible. That's actually a theorem that was quite useful in problem sheets we did, but didn't come up in this exam, I don't think. Other side, what we got here? The fundamental theorem of homomorphisms, a screenshot from the solutions of a problem sheet that I did a while ago. Wrong homomorphism definition, this came up, thankfully. Just that, pretty much. Pardon me, oh dear. Quotient ring, that I was talking about earlier, quotient group, Eisenstein's criterion, minimal polynomial, the simple algebraic extension. Couldn't tell you what that means. But yeah, let's get into this exam though. I'll do what I did before, of just first off flashing all of the questions, and then we'll go through them individually. Okay, so question 1 is Yep, you can pause and read, but I'll be going back through them over anyway. Got a group there with a table. I will say, in terms of difficulty, algebra was one of the exams where I really was not looking forward to it, because I was in the library at around 10:30 the night before, just thinking, do I simply accept that I am never going to be good at this? But the exam was all right, thankfully. It wasn't as painful as some of the past papers we've been given. I mean, as some of the problem sheets we've been given. At least not in my opinion. So yeah, that was great. I've had this up for a while now. Yep. And same as before, section A has 60 marks. You answer all of those. Section B has 40 marks. You answer 2 questions from those. You can answer more, but your best 2 questions will be what counts towards your grade. Yeah, I'm glad that's best, because You know, if it was your worst two questions go towards your grade, you've got to think very carefully about the questions you pick. But here we go. Yep, section B now. Things get a little bit harder, in my opinion at least. I imagine there's someone watching this that could do this in their sleep, as in they're watching this, reading it and answering it all in real time. Ooh, that's the top of that one. Then question 8, and then question 9. That's the last part of the question. Fun fact, I am fairly certain question 9 was effectively the exact same as the second, so our second assignment only had one question. I'm fairly sure that question is the exact same as this question here. I think. And I'm pretty sure I found this question on a physics forum when I was trying to find answers for that assignment. Crazy. But yeah, let's go through this. I thought I'd just put the desktop lamp on just to make things a bit more ominous. But question 1. Okay. So yeah, this wasn't too bad. It's just, you know, raising these all to the power of -1. I forgot how to do that, but I just guessed, okay, hold on. I'm pretty sure if I just multiply the left by t to the -1, that'll go to e, then just put that there. Then s to the -3, put it there, and then just rinse and repeat for both sides and get an answer. That's what I did. If it's correct, who knows? I guess I'll never know. Now let's see here. The set is a group with respect to an operation that most of the entries of the operation table of that have accidentally been erased, and we were left with an incomplete version of it. And at first I thought it was going to tell me to complete this table, which I find so boring, but thankfully it didn't. I'm sure that I is the identity element of gamma, that's fine. You just use that part there, that I think, is that iota? I don't know, times whatever symbol that is, I still couldn't tell you. Is that, yeah, identity. This one I could not do. I was thinking to myself, 5 marks, it can't be that difficult. It should technically be the same difficulty as this one. But yeah, nah, this exam was 3 hours, by the way. I answered all the questions in about an hour and 20 minutes. I came back to here for 10 minutes and said, yeah, no, I give up, and I just left the exam. And then my friend told me it's because if it was commutative, then you'd have to mirror these two elements here. But of course, each element can only appear in each row and column once, so that didn't work out. Of course, I couldn't change my answer then, but hey, it's something at least. Not cyclic. How do I prove this? Oh yeah, it's not commutative, so it's not cyclic. What was that sound? I think I'm the only one awake out of my house of 8 right now, so... Oh, could this be the lost tapes of the undergrad? Who knows? But let's speed this up. Gamma has a cyclic subgroup of order 3. Yeah, if you square phi, you get that. That times phi, you get I. Order 3, not too bad. Yeah, I've seen some nonsense in like the problem sheets that made me think, okay, yeah, I'm absolutely finished for this, because I just don't know what it's talking about. But yeah, like I said, the exam wasn't too bad. So that's the first 2 questions. A set with a group with respect to operation defined by this table here. Show that it's not cyclic. My first thought is, okay, can I prove that it's not abelian? And I did that, I believe, with this diagonal part here. QSA, QQ. So yeah, that's not mirrored, so not abelian. Simple. Show that G does not have a non-cyclic subgroup of order 4. Now, I could not think of a theorem that did this, and when I spoke to people after the exam, they couldn't either. Most people just went through all of the subgroups that are generated by an element and said, yeah, all subgroups are cyclic as they are generated by an element. Therefore, there are not any non-cyclic ones. as in kind of like a proof by exhaustion kind of thing. But I don't know if that's valid. Like I don't know if that proves, like all you've shown is that there exists subgroups that are cyclic. You haven't proved that there aren't any that are non-cyclic, and that's what I did. I did the exhaustion thing. So I really don't know if I'm gonna get those marks there. And I was thinking because I basically did part C by doing part A with that method. So I thought, okay, I've gone wrong there somewhere, but who knows? Question 4: consider the ring that provide brief justifications to your answers to the following. Does 7 have a multiplicative inverse? If I remember correctly, it was 7 times 13. Yeah, because that remainder ends up giving you 1 if you divide that product by 15. Find all elements that have a multiplicative inverse. Off the top of my head, it was 7 and 13, 2 and 8, 4 with itself, 14 with itself. Oh, sad note, if it looks like I'm moving my thumb weirdly, I messed it up in the gym earlier, trying a weight I shouldn't have. Whoopsies. I can't remember it anymore off the top of my head. Yeah, that might be it, to be honest. Oh, that's the other one. Okay. Is R an integral domain? No, because it has 0 divisors. Is it a field? No, because it's not an integral domain. Is 0 an ideal of R? I believe I put yes for that, because it's closed under addition. 0 is part of it, and if you multiply this with any other number that's in R, you still get 0, and that's in the ideal. Is that an ideal? I said no, because 3 plus 6 is 9, and that's not in this ideal. In there, does f equals 0, 5, 10 have a multiplicative identity element? And that would be 10, because 5 times 10 is 50. Divide that by 15, the remainder is 5. So yeah, and then 10 times 0 is 0. 10 is the identity element. Is it fulfilled? I said yes for this one, because all elements have a multiplicative inverse except for 0. But if you have, I believe it is more than one element in a field, 0 won't have an inverse or something like that. I remember seeing a corollary like that in the notes, so I mentioned that. Okay, question 5. And this question scared me a little bit because of the matrices, but thankfully it was about ring homomorphisms that I had studied quite a bit. So consider the ring that, with respect to a usual addition and multiplication of matrices, which of these are ring homomorphisms and why? In the end, I got only H to be a ring homomorphism. With all of the others, I believe the identities don't match up. So yeah, as in the identity of this is the identity matrix, the 2 by 2 identity matrix, and the identity of Z is just 1. Wait. Oh no. Oh wait, no, that's fine. Yeah, no, that's fine. That's cool. Because 1 is the multiplicative identity, 0 is the additive identity. I thought I messed that up. Okay, we're good. Yeah, so for F, G, and K, the identities don't match up. So if you plug in 1 here, you get -1, 0, 0, -1. That's not the identity matrix. Plug in 1 here, again, you don't get the identity. Plug in 1 there, you don't. Here you do, and same with 0. If you plug in 0, you get the 0 matrix. I do not know if I talked about 0 for H in this one. Honestly, I couldn't, but I specifically chose to mention identity to look at the identities if they lined up, because I was looking at regular homomorphisms a couple days before the exam, and I tried just intuitively seeing if like a function was a homomorphism or not, and I got it wrong. I thought it was not a homomorphism because of the identities, and it actually was, because the identity thing only applies to ring homomorphism, not regular ones. So yeah, I knew I was gonna get that. I knew I got that. Part B, for the ones that are ring homomorphisms, find their kernel and image. So just for H, their kernel is just 1, what lines up to the identities, I guess 0 and 1. But yeah, Section B. Now, the two questions I did were question 6 and question 8. We'll get to 8 in a second, but yeah, I give an example of a non-trivial homomorphism, f to z, f of z to c, where z is the group of all integers with respect to ordinary addition, and c star is the group of all non-zero complex numbers with respect to ordinary multiplication. The homomorphism I chose to write down was z mapping to, I said n mapping to z to the n, where z is a complex number and n is an integer. That was the one I chose. I believe that works. I didn't prove it, I didn't write down the proof, but I remember it, I remember thinking that I'm pretty sure it does work. The image, I think for that I just put z to the n where n is a natural number. I didn't know what else they wanted from me. The kernel, I said the kernel is, so the kernel would be whenever z to the n equals 1, and of course that's when n equals 0, but that's also cyclic, right, with roots of unity, I think. So I said 2n pi I, where n is an integer. That's the kernel. No idea. Oh, does that make any sense? Ooh, I don't know, but yeah, I haven't looked at de Moivre's theorem since, I think, autumn term of this year, so back in November. Yeah, give an example of a subgroup of C star which is isomorphic to the quotient of Z. For this, I used the fundamental theorem of homomorphism. So glad I wrote that down. I don't know if I explained it correctly, but hey, I mentioned it and I included the things in there, the domains we're working with. Oh, pardon me. Question 7. Any man who attempted this, I believe, should be sent to an insane asylum and get a thorough medical examination on their mental state, because why on earth you would choose anything to do with permutations willingly doesn't make sense to me. But we'll look at the questions anyway. Consider the symmetric group S8 of all permutations on S equals 1 to 8. Give an example of two distinct subgroups of S8 that are isomorphic to S4. I can't do any of these. I promise you now, I cannot do any of these. For this one, I would just guess two random permutations in S8 and hope they aren't conjugate. But the rest, it's literally, you could flip a coin and get a more accurate result. The last question of question 7. The last part of question 7 is last two parts. Give an example of a non-cyclic subgroup of order 60 in S8. You may assume that the alternating group A5 is not commutative. Honestly, could not tell you what the non-commutativity of A5 has to do with S8. Who knows? Let sigma equal that, and is that Tor or Tau? My physics teacher said Tor. The Greek friend I have said Tau. Yeah, it's really a battle of two dark sides on that one. But find rows such that so honestly, I think I could do this one. That's just breaking this down into its disjoint composition cycles, and kind of just slapping them on top of each other. You ain't got to prove it either, just got to find it, which is great. Question 8. I love this question, except for Pi, because I made a dumb mistake. But let the real number alpha be a root of the polynomial g equals x to the 117 plus 15x minus 21. What is the minimal polynomial of alpha over r? That's just x minus alpha. Simple stuff. We'll show that g is irreducible over q over the rational numbers. Now for this one, I used Eisenstein's criterion. But what I don't get about this is that in the notes it said that if you prove that Eisenstein's criterion, what a tongue twister, Eisenstein's criterion holds, then it means that f is irreducible over the integers and therefore irreducible over the rational numbers. I don't know if I'm being an idiot, but I don't see how that works, because z is in q. So if just because there's no I don't know, it could just be me. But yeah, I used Eisenstein's to say that it's not it's irreducible over Z, therefore irreducible of Q. This, I had this written down because I knew if this came up, I would have no idea what to do. Got it right in that corner there. Just replaced the F with a Q. I replaced the N with the degree of the minimal polynomial, which is that. And then, yeah, you just bless from there. What is the minimal polynomial of alpha over E? I think I just put this polynomial here. Yeah, because I showed that it was irreducible. Therefore, if it's irreducible, it is the minimal polynomial, or a minimal polynomial. What is the dimension of E over Q? Now, I was hoping this wouldn't come up because I just didn't revise it at all. It didn't come up in any of the problem sheets, didn't appear in any of the assignments. So I thought, okay, I think if I take a risk and say this won't come up, I'll be okay. It came up, and I randomly guessed the degree of this polynomial -1. So I put 116. I just guessed that off a whim. I checked the notes later, and it's just the degree of the minimal polynomial, so it's 117. When I tell you I fell to my knees in my university library when I found this out. Apparently it was somewhere in this cheat sheet. No idea how I was supposed to find this though. You know what I mean? It's just impossible to navigate. Like, what's going on? Yeah, I can't find it. But yeah, anyway, there's that. Question 9. Yeah, I remember being confused for this one because I was originally going to do this because I didn't do too bad on the second assignment, so I think I had a good idea what the answers would be. But when I was doing this, I thought, okay, number of elements of E, okay, that's going to be 2 to the 4, that's 16, okay. And then part B was show that every non-zero element of E is a power of alpha. That wasn't too bad, I don't think. That wouldn't have been too bad, I don't think. I remember getting a good amount of marks on that question in the assignment. And then for these two parts, show that E has a subfield of order 4, but no subfield of order 8. But I thought, hold on, with Lagrange's, both 4 and 8 divide 16, I mean. So what the hell is going on? After the exam, the people that did this question said, oh yeah, you have to talk about the multiplicative groups. So you -1 from each of the orders. So, what was it? Yeah, 4 minus 1 is 3, 16 minus 1 is 15, 3 divides 15, but 7 doesn't divide 15. That basically sums up what these questions here talk about. But yeah, that's that paper. Overall, my performance, I thought it would be about a 2 out of 10, but honestly, without jinxing anything, I'd give that a 6.5 out of 10. Yeah, I can't be mad. I made a few silly mistakes like that commutative one in question 2. Like I remember I kept like getting the terms inverses, opposites, and identities mixed up while like writing my solutions. So I may have lost a couple marks on that. But I've rambled enough. This is longer than any of my other videos. Also, thank you for their support on the videos. I checked like an hour and a half ago, saw that I gained like 60 subscribers and over 1,000 views on both of my last videos. Unbelievable. Thank you very much. I can't say thank you enough, but have a good day, guys, or night, or evening, or week, or year, or nap, whatever you're about to do. And yeah.